identities.
All right, so on this one is state what the expression equals. In other words, these are all Pythagorean identities. Remember, you're not going to have time to look down. You're going to have time just to write or read and react. I love it. I used to say that all the time on defense to linebackers. Read and react, read and react, read and react.
Wait, is this
Sure. Okay, are you ready? Huh?
Okay, just those three.
Clean sheet.
How many is there?
There's 8. So now, to be fair, the identities all say sine squared plus cosine squared equals 1, right? You're not going to write them in order 1 through 8. There's no way you can hit the margins exactly without looking. Just list your answers 8 in a row. It doesn't matter how far apart they are, just list them. Move your hand out a little bit and write. It's not going to be neat. It's going to be effective. So, now remember, sine squared plus cosine squared equals what? All right. So, what does cosecant squared minus 1 equal? Cotangent squared. Yeah, see? I'm going to mix them up so you have a one expression answer.
Does the C minus 1 is equal to cotangent squared?
Yeah. Didn't you know that already?
Yeah, but I thought you said
All right, here we go. Ready?
Are the signs?
Just those 3. Remember, each 3 gives you 9 different ones, right?
Right. So it could be.
Right. Okay? Some could be repeated. All right, here we go. Ready?
Hoping it will.
Psh, wieners. 3, 2, 1.
You really did say that.
Yeah, you did.
Oh my gosh, people are looking at their note card and writing. It's not supposed to be like you're supposed to recognize these.
I don't.
Well, that's because you haven't worked with them long enough.
I'm just like 4 already.
You would be. You only work on trig from 9 to 10.
I don't even know what number we're on. It goes too fast for me. I got
Every 4 seconds isn't fast.
the last one.
Oh, that was a quick one.
Oh, that was really quick. You're all but one.
Nice.
Oh, yes.
See?
I missed number 4.
How many were
Got that one right.
8. You probably got 0.
I got those two mixed up.
Good. Nice job.
I got that one.
Yeah. Turn it in. Put your name on it. Turn it.
I missed a lot. I looked down.
I missed. Hold on, I think I missed.
I thought you.
Some people are changing them now. Look at it. Like Drew, he's changing them.
I didn't really get it, so I didn't.
Nice job, Drew. All right, go ahead and hand them up.
Floppy, scrap thing.
Drew changed them. He's a cheater. All right, we're moving on.
I got all but number 6.
I missed 2. I didn't even get a 2 down.
I missed.
I looked down and missed
We should
it.
do this more often.
Yeah, it is.
We are. I just said. I just forgot these. All right. Now be careful, Drew. You're gonna work for a nerd someday, so you better be nice to him. Double angle formula.
How do you know that?
It's right here in Bill Gates' top 10 reasons to graduate high school. You things you better know. Anyway, sine of 2u, double angle formula. Sine of 2u. Only if you want to remember them. They go on your identity note card that you can use for any quizzes or homework. These are the double angles. All right? These are the double angles. Go ahead and write them down. Yep, I think so. 6'4", the double angle and half angle.
A lot nicer with audio.
I hope so. So I'm giving it a go. Double angle. Now, these are all derived from the sum and difference identities of cosine. I'll show you what I mean in just a minute. But these are used in calculus quite a bit, so we don't have time to derive. We just have to know them. For instance, if I asked you to, let's say, verify Identity number 1. You can do this with any of them, but identity number 1 is probably the one that people see it the quickest. Sine of 2u, if you ask to verify it, you could either start on the left or start on the right. Well, either way you start, if I had to verify this identity, I'd write sine of 2u as sine of u plus u. That's equal to sine of 2u, correct? Well, this is the sine of two angles added together, the identity you just had for sum and difference. So it would be sine u cosine u plus sine u cosine u. And going back to what we said earlier in the homework, these are actually like terms. You can combine them to get two of them. 2 sine, I'll put that first. 2 sine u cosine u. A lot of people try to take the easy way out, the non-academic way out, and just try to, I don't even know what kind of logic it's called, but they say, oh, you just factor the 2 out, where'd the cosine go? No, you don't factor anything out. This is actually, it took 4 steps of work to go from here to here. So every time you use this, you're saving 4 steps of work. That's what it is. That's what an identity does. It saves you time in solving problems. All these are 4 steps of work to go from here to here. This one, also 4 steps of work. You don't factor anything. These are all just quick trips through lines of logic. That's it. If you don't believe me, here's another one. Let's try this one. Cosine 2u. A lot of people think you factor out the 2 and then you square it somehow. Yeah, that's just because they aren't even really listening. Cosine 2u is the same as cosine u plus u, right? That's the cosine of 2u. Well, you have an identity for that, so it says cosine u minus sine u, right? The v is obviously being replaced by u. So now you have cosine squared of u. That's good. That's in your answer, minus sine squared of u. If you notice, that's the first one, cosine squared of u minus sine squared of u. All right? To get this one, 2 cosine squared, they actually just make a substitution for sine. They put in 1 minus cosine squared of u. So you can see that when you do all this, the identities are shortcuts to help you do problems that are quicker. Cosine squared of u, and put 2 of them here. 2 cosine squared of u minus 1. So they're all just identities. There's no factoring. There's no distributing. Yes?
So to make the sine squared of u like a less.
You could, yeah. And you can work it out. All right? So you can do that with any of them. These are all meant to be shortcuts for solving problems, so you're not wasting your time doing mundane work every time you want to use one of these. Okay? But there is no factoring. There is no distribution, no foiling, nothing like that. Nothing algebra related. It's all trig. All right? All right, ready to go on? I think you're ready. Ready, Trevor? Let's give this a go. Here are some half angle identities. So,
Thank you.
yeah, there you go. These are in your textbook, so if you don't feel like writing them down now, that's fine. You can put them in your note card. You'll need them again. There's only 8 of them, so that's not so bad. And you kind of see why now you need a note card to keep them all straight. Those that have high aspirations of going on, like to the next math class, you'll probably use these quite a bit in your second semester. Yeah. But you'll see in a minute there's a lot of, they're the same thing written a different way. Okay? For instance, if I take number 1 on the right side and I say, first of all, let u equal v over 2. Okay? Watch very carefully. Let u equal v over 2. This becomes the sine of u, doesn't it? Equals plus or minus the square root of 1 minus cosine 2u all over 2. Isn't that nifty? The let statement is very powerful. Now, if you square both sides, look what you have. You have the other side. So why now, in this last 5 years, has the author decided to take this one identity and write it 2 different ways? Well, high school kids don't see them as one anymore. They used to, but not anymore. So they boiled it down to make it easier for you to try to help you work them. Yeah. You can do the same thing. Okay? Well, they're in your textbook. I mean, if I go on, you can always go back to your textbook and write them down. You might spend some time outside of class doing this. That's fine, but I'm not going to write down all 8 of them. I don't have time for that. You have time for it, but I don't. So, with that said, that's how the identities are related. Take a look at something very nifty. Do you see number 2? What happens if I multiply both sides by 2? What do I get? 2 cosine squared of u equals 1 plus cosine 2u. What if I subtract 1? Yeah, it is. 2 cosine squared of u minus 1 equals cosine 2u. Yeah, it's just written a different way. It's all the same thing. The Pythagorean rewrites we just went through are easier because they don't have square roots. As soon as you throw a square root with a fraction, people, well, that's because they took the square root of something squared. No big deal. Yeah, but how'd they get this one over here? Well, easy. It's a let statement. Let u equal v over 2. And you're going to say, well, why is that needed? And I'll tell you, it's because you have to integrate from a to b plus or minus the square root 1 plus cosine b over 2 in calculus. This is the only way to get out of that problem. This identity right here. That's why it's there. So you have it somewhere. You can reference it later. Everything goes from the top down. Everything, especially in academics. That's why before high schools never taught calculus, because they taught algebra. Well, where did algebra end up? In 8th grade. So they had to put something down in high school. It's calculus. Guess what? In the next 10 years, they want to take geometry, move it to 8th grade. Where's algebra going to go? 7th grade. Where's calculus going to go? Junior year. What's going to come next? Either high-powered stats or calculus 2. It always gets pushed down about every 30 to 35 years. So eventually, when you say you can't do 7th grade math, you'll be right. It'll be your algebra and geometry you won't be able to do because that'll be the norm.
In like 60 years, algebra's gonna be like 6th grade, 5th grade.
And it already is. In Champaign-Urbana, they already teach algebra in 5th grade.
I'm not good at it though.
Well, I didn't say that. I just said they teach it. They don't teach it to everybody. They teach it to the ones that can handle it. So, anyway, moving on. How do you use these identities? Easy. I'll do these 3 problems because it looks like a lot of work and it's actually not. For all these, you're going to need, I think you're going to need a reference picture. You're going to need something to reference everything. And it tells you where to put the angles. See this theta? It says it's in which quadrant? Between 180 and 270. Third quadrant. So, I can draw it. This tells me how to label my sides. In the third quadrant, how am I going to label this picture? Where's the 4 going to go? That's the adjacent side. 3 is going to be the opposite side. So hypotenuse is going to be what? 5, right. And they're both going to be negative because it's in the third quadrant. Cotangent is adjacent over opposite. You should know that by now, I would think. Anyway, -4, -3, and 5. So, first up, sine of 2 theta. All right? Now you're going to say, I don't know what that equals. Well, sure you do. We just wrote it down. You don't have a picture that says 2 theta. This picture is a theta picture, not a 2 theta picture. How do you know the difference? Easy. Because 2 theta is between 540 degrees over 360. It's that funny multiplication thing. If you multiply theta by 2, you multiply both sides by 2. we don't have that picture in that quadrant. Our picture's over here. So we use the theta picture. To take 2 times sine of theta, that's cosine of theta. What is the sine of theta? Yeah, -3/5. And the cosine is -4/5. Yeah, you get 24/25. Nice. Yeah.
Where did you get
The directions say find the value for sine of 2 theta. The first identity I gave you said sine of 2 theta equal to sine theta cosine theta. That was the first new identity of the day. I just put the fractions in for the ratios. All right? So, that takes care of that one. Now you've got 2 ways of getting the next answer. Actually, 1, 2, 3, 4 ways. You can use any one of the 3 identities, or you can use a Pythagorean identity. Sure.
We have to find the exact values for sine, cosine, and tangent.
Sure. Cosine of 2 theta. You can use one of 3 things. One, I'm going to use, well, a lot of you would say, they're too long. Well, no, they're not. You can do that one. Cosine squared minus sine squared. That's fine. Use any one you like. Yeah, you do the same thing. Except this time you have to square it after you write in your ratio. That's what the 2 means. You write your ratio first, then you square it. So the cosine of this is going to be -4/5. The sine of this is going to be -3/5.
So would you just
What did you say? Yeah, square them first. 16/25 minus 9/25 equals 7.
Is it negative roughly?
Yeah, but I think when you square it, it turns into positive.
Oh, yeah.
So it equals 7/25. Now let me show you something about thinking. What is the sine squared of A plus the cosine squared of A equal? 1, right? That means 1 equals, that means that the cosine squared of A equals 1 minus the sine squared of A. Correct? All right. What happens if A equals 2 theta? That means the cosine of 2 theta would equal the square root of 1 minus the sine squared of 2 theta. Yeah, it's the Pythagorean, it's the one we had earlier. So all you have to do, I had to explain it, but what a lot of people do is in this case, they take 1 minus 24/25 squared, and they take the square root of it. That's their answer. Do you think you get 7/25?
Probably.
I don't know. Give it a go.
I'm guessing so. Otherwise, you would have thought so.
I don't know. I just thought of it. I just made it up.
Did you really?
No, actually, that's how I used to do them all. I would never go back and recalculate. I would try to use my identities. Very good.
usually tell us not give something writing down? This is-
Yeah, that's when you're solving multiple problems, like triangles. Yep. But see, I had an ego. I had confidence. Most of you don't think this way. I just wanted to show you that thinking that way might be beneficial at times. Okay? Now, for tangent,
By the time we have text, we'll come up.
for tangent 2 theta, I would also use sine 2 theta over cosine 2 theta. Okay? Yeah, so what do you think 24/25 divided by 7/25 is? Surely you've seen this enough since September to recognize it by now. You're actually going to punch it out on the calculator?
Yep.
You can't just sludge it out and be done with it?
Sure you can.
47.
24 seconds.
Okay, 27.
All right. So that's how you use identities. And your calculator. All right? But, all right, so let's try this one.
That's 24/7.
Yeah, what? Sine theta over 2. You don't have, well, where is theta over 2 at? Where's theta over 2 at? Which quadrant? Fourth. Negative 45 to 0, right? That's in the fourth quadrant. What quadrant? Oh, this is also in the fourth, isn't it?
Yeah.
Negative 45.
I divide everything by 2. How else are you going to get theta over 2?
Oh, wait.
Yeah. Huh?
Okay, yeah. I was doing it backwards.
That's okay. I did it forwards. It's fine. So we got to draw a triangle in the fourth quadrant. There we go. How do you label it? Well, cosecant is by definition what? 1 over sine? Yeah, hypotenuse over opposite. Can the hypotenuse be negative yet? No. So that's going to be 5. The opposite is going to be negative 3. The adjacent is going to be 4. All right, ready? Well, what identity are we going to use? The sine theta over 2 equals what? Oh, contrary. There's one thing before that.
Plus or minus the square root of.
Good. I like these answers. These are like high-powered, high-profile answers. That's a two-part answer. One is you make the call. There used to be, when you watch NFL games, there was a situation where they would have a play, and you had to pretend to be the referee, and you had to make the call, and it was always a 50-50 chance on whether you got it right or not. You know, all those little teasers keep you interested in the game. Anyway, on this one, you have to make the call, whether it's positive or whether it's negative. How do you know that? You simply look to see where half the angle is. So if it's in the fourth quadrant, is the sine of the angle positive or negative in the fourth quadrant? How do you know? Well, look, I've showed you this how many times? Yeah, in the fourth quadrant, is sine positive or negative? So you're going to pick the negative. Negative. That's how you make the call. 50-50 chance, a little reasoning, a little knowledge can help increase your odds for the right guess. Because it's in the fourth quadrant. Yeah.
Super.
Super.
All right, so
That's the word.
what is the cosine of theta equal to? Here's my theta picture right over here. Yeah, it is 4/5 over 2. So I have negative square root 1 minus 4/5 all over 2. Huh?
That is not fraction.
What are you talking about?
It didn't rain.
Well, no, it's not going to. Well, first of all, I'm going to do this.
Root twice. One.
5.
Well, sure, I want to get rid of the denominator.
Oh, okay.
I told you I do this all the time. I don't think you guys were believing me back in September. You thought it was a crazy move. But I use it a lot. So I have 5 minus 4 all over 10.
Do you ever get word back if that's okay or not?
Well, some people are analyzing it and they think it's okay. What negative? Oh, it got swallowed up by the equal sign. I'll make another one. So that becomes the square root of
So,
negative 1 over square root of 10, right? Now you can rationalize it for fun. You betcha. That is equal to the sine of theta over 2. What's theta? You never did find it. We'll do that next section. Could find it, but we didn't.
In 5 or 6, 6, 5.
I hope so. Soon. All right, any questions? I don't know. I didn't look.
There's 6 of them.
6 of them? 7 of them?
I think there's
Oh, wait a minute. We got to go back and do cosine, don't we?
Yep.
And tangent.
And.
Well, I think I'll do it like this. The square root of 1 minus negative square root of 10 over 10 squared.
Wait, why did it all two?
The directions?
Didn't it
What's
say
that?
sine?
Cosine of
So what is 1 minus negative square root of 10 over 10 squared?
So you can do that even with the other formula?
Well, sure, if I have cosine squared of A plus sine squared of A equals 1, I'm just letting A equal theta over 2. As long as they're the same, it works.
Okay.
It's the same theta over 2. I mean, you're not changing the angle halfway through the problem. Yes?
So negative for the cosine of theta over 2 on plus or minus.
Yeah.
Is it
Some people do this, and some people do this. See if it works. 1 plus 4/5 over 2. Is that what you meant?
Well, I meant because, like, is it going to be the negative square root of it?
Oh, and the fourth quadrant is the cosine positive or negative. It's right up here. See? ACTS. Positive. So it's not going to be negative. It's going to be positive. In fact, it's going to be 9 over 10. You know, once you slid that out, I think. So this is going to be 3 square root of 10 over 10, isn't it?
Wait, why did you do that two different ways?
No, I said you could do it this way.
That's all you gotta do though.
And then Marissa said, do you have to do it this way? I said, no, but you can.
So how would you finish the top? Explain that to me.
Well, that's an algebra question.
Why are you only taking a third of the top?
10 over 100. So what is it? 1 minus 1/10. Sure. Is what? What's 1 minus a 10th? 9/10. Nifty. 3 square root of 10 over 10. Over 2? I did. Over here. That's because I did 2 different approaches. This one uses the half angle identity. And this one uses the Pythagorean identity.
Okay.
Why didn't we have a plus or minus in front of the square root sign?
We do, right here.
Oh,
But we make the call it's going to be positive because it's in the fourth quadrant.
gotcha.
Okay? There's a lot going on, isn't there? This is great. I know, there's a lot going on. It's fantastic. 4 minutes. Oh, we got plenty of time for another one. Better get going.
Tangent.
Tangent.
Yeah, tangent.
I think that's pretty easy, don't you?
It's just that answer divided by the other one.
Yeah, it is.
Yeah, you take sine divided by cosine.
Yeah.
You can do that on your own. You guys are big kids.
Well,
Well, only when you want to be. Oh, I can't believe you want me to go out. I'm old enough. You just let me do that? I don't know how to do that. I'm not old enough. I love that.
Double.
Yeah, it is.
Standards.
What's wrong?
I said I'm not follow but I'm okay with that.
That's good. Moving on. Last one. The cosine of 165 is not on the unit circle. However, Drew knows that to find the exact value, you need to use the unit circle. So Drew has theorized that 165 must be half of what angle it's on the unit circle. What is it?
330.
Yeah, 230.
All right, so the cosine of 330 divided by 2 is the same as the cosine of 165. Are we all in agreement? 165 is in which quadrant?
The second.
Second. So when I do my identity, I have to pick plus or minus the square root of 1 plus the cosine of 330 divided by 2. Which one am I going to pick, the plus or the minus?
The plus negative is the second.
Yeah, it's in the second quadrant. The cosine of any angle in the second quadrant is going to be negative. So that means I have the negative square root of 1 plus, what is the cosine of 330? I forgot. Negative square root of 3 over 2?
No, square.
Positive square root of 3 over 2, thank you. And a 2 right there. I'm going to do my standard move until it's illegal, which not yet.
It's going to be illegal.
Well, it's still up in the air, still debatable. I'm running with it though.
I don't think, how can you make it illegal if it works?
Well, because it's too easy. Once this gets out, it's going to make math really easy.
Did you seriously come up with that is?
Sure. Actually, we came up with it in trig one year. Some kids say, can you try this? So I don't know. So you got 2 plus the square root of 3 all over 4.
Wouldn't it be 2 plus 2 square?
Why? Doesn't that 2 get knocked out?
Why didn't you cross out the 2?
What 2's?
I didn't just wait, why is there 2 on the bottom?
That'd be a 4, and the square root of 4 is 2. Look at this. This looks like one of those racing slick answers. It's got like the vertical line or the horizontal lines going, you know, like a racing side of a car. I like that. This test's going to be a killer. It's a 2-dayer. Oh. All right. So on this page, we'll go through what, 1 through 15 odd. Tomorrow, we're going to have time for 10 for 10. Woohoo!
You didn't get to 15.
Yeah, but don't sell yourself short. You got skills. Yeah, you got skills. What page is this? Page what?
500.
500.
500 exactly. 6-2, right?
Is that homework by the answer? It's like 1, 2, and all.